The sample solution and the identification reagent were added together and we observed some changes. Through the observation of changes, we concluded that the existence of such anion like sulfate, sulfide, carbonate or bicarbonate or phosphate, nitrate, nitrite present in the solution. So solution is very important. Most of the cases, if we do not make any solution, the reaction will not initiate because it is the mandatory and it is the primary requirement for conducting any reaction, for carrying out any reaction, the contact between or among the reactant is very important. And solution is the best process to make contact with the reactant for a successful chemical reaction. Now, the solution is one of the techniques through which we can create contact among the components, among the reactants, which are going to be participated in the reaction. So how we can prepare the solution? Solution always containing two components. One is solute and another one is solvent. Solute and solvent mix together and we get solution. Now how we can define the solute? The component which is present less amount in the solution is called solute. The less amount or little amount that we are using in a solution is called the solute. And solvent, large amount. The component that we are using as a large amount to dissolve the solute is called the solvent. So we can define simply the small phase that we are using in a solution is called solute, and the large phase that is used to make the solution is called the solvent. The solute and solvent together preparing solution. Today we are going to talk about the preparation of stock solution or standard solution having the strength, having variable strength. So here I have used another word, is stock solution. You can guess the word like stock. We are going to, after preparation, we are going to stock it. We are going to preserve it for several days for carrying out several experiments. And another one is standard solution I have used. Standard means the strength. That means the concentration of the solution is known. We know the concentration of solution. So usually the stock solution is also the standard solution because without knowing, we cannot prepare the solution. So whenever we are preparing the solution, sometimes we calculate before, sometimes we calculate after. So whatever the calculation is before or after, no matter, the main objective of this is to find out the concentration. That's why it is standard solution or stock solution. So we usually prepare the solution with an definite concentration and preserve it for several days to carry out several experiments. Because every day we cannot prepare the solution because it is time consuming and it is not much required. Yes, sometimes the solution need to be prepared freshly because if we preserve it for a long time, the quality of the solution could be changed, could become lower. That's why sometimes for some of the compound, we need to prepare fresh solution. But most of the cases we do not. So whenever we do not need, then we can prepare the stock solution with a definite volume and definite strength. Then we can preserve for further application or utilization. So the name of today's experiment is preparation of stock solutions having various strength by applying the concept of solution stoichiometry and the calculation of molecular weight of compounds. Here a few things could be unfamiliar with you, especially the stoichiometry. Stoichiometry is nothing. It is when we consider the component which are going to be participated in the chemical reaction. If we measure them, if we mention the amount of those reactants, then they are called the stoichiometric relationship. So when we are making the relationship among or between the reactant with the concept of their amount, that means how much present in the solution or how much component present in the reaction and how much product we are getting. So there is a relationship. For example, if we decompose 100 grams of calcium carbonate, we will get 70 grams of calcium oxide. So how much we are decomposing and how much we are getting after the reaction. So how they are related to each other from their mass, then that is called the stoichiometric relationship. In our other chapter in the theoretical theory, CHM 117, we have the complete chapter on stoichiometry. There we will details more. Here, whenever we require, we will again use the word and our concept. The objectives are the basic laboratory practice to prepare the solution, because from now we need the solution to carry out the reaction. However, you have already experienced that in the identification of anion, we had been preparing the solution. So next we need more. So we need to know how to prepare the solution. So this is the objective, basic laboratory practice to prepare solution. To understand the knowledge about molarity or molar solution, this molarity is one of the terminologies that is used to represent the concentration of a solution or the strength of a solution. Stoichiometry determines the amount of product reactants that are produced or needed in a given reaction. So whenever we are talking about the amount of product and the reactant that will be required or that will be produced during a chemical reaction is called the stoichiometry, concept of stoichiometry. The preparation of solution. A solution is a homogeneous mixture created by dissolving one or more solute in a solvent. No matter, most of the cases we can think that the solvent will be liquid. It is not necessary that solvent will be always liquid, but most of the cases solvent is liquid, but solvent could be gas, could be solid. Say in the alloy, when we are mixing silver with gold to make the gold stronger, the solvent is gold, solute is silver. Or in the air, there are lots of gases, especially the nitrogen, the oxygen, and other very trace amount. So if we consider that nitrogen is a large amount, so other components are dissolved, mixed up with the nitrogen. So all here the gas. So these are the variation in the solvent and solute. What we need to remember that the solvent is the large phase, which will be used in bigger volume, large volume. On the other hand, solute is the small phase, the component of the solution which is used as a small amount. Solution with accurately known concentration can be referred to the standard or stock solution, what I have just told earlier. These solutions are brought directly from the manufacturer. Sometimes the solution is collected directly from the manufacturer, or formed by dissolving the desired amount of solute into volumetric flask of specific volume. Stock solutions are frequently diluted to solution laser concentration for experimental using in laboratory. Okay, this is another thing. Sometimes the stock solution could not be suitable for carrying out the experiment. say we have created the concentration of 1 molar, but our designed experiment require 0.5 molar. That means less concentrated solution is required. In that case, we can take some stock solution and we can dilute. Dilute means decrease the concentration of the solution. So during the dilution, we will add more solvent. Very simply, we can alter the concentration of the solution. If we want to decrease the concentration of the solution, we can add solvent. If we want to increase the concentration of the solution, we will add solute. Simply, addition of solvent will decrease the solution. Addition of solute will increase the solution. So here, what is the mole? You already been familiar with the word mole when we had been discussing about the ionization energy, 1 mole of hydrogen. When we had been talking about the nuclear binding energy calculation, there we used the word mole, which refers to the 6.023 into 10 to the power 23 particles or atoms or molecules present in a gram molecular weight of a substance. So molar weight or molar mass is the weight or mass of 1 mole. That means 6.023 into 10 to the power 23 particles or molecules or atoms of a substance. For example, the molar mass of sodium hydroxide is calculated as sodium 23, oxygen 16, and hydrogen 1. How we can calculate the molar mass of sodium hydroxide or molecular weight of sodium hydroxide just by using their formula. And sodium hydroxide, the sodium is 23, 16, and 7, 1, so total 40 grams per mole. So 40 grams of sodium hydroxide, if we collect 40 grams of sodium hydroxide, it will have 6.023 into 10 to the power 23 molecules of sodium hydroxide. So the representation is something like this. Now, if we dissolve this amount of sodium hydroxide in 1 liter of water, then the concentration will be 1 molar. So this is the most frequently used unit to represent the molarity and the molar concentration. All right. So if we dissolve this gram molecular weight of any of the substance in 1 liter, so remember that the solute should be in the gram molecular weight and solvent should be in liter. Then the solution will have the concentration of 1 molar. Now, depending on the amount of solvent, depending on the amount of solute, we can change or we can alter the strength of the solution or the concentration of the solution. The required equipment, weighing paper, volumetric flask, funnel, and pipette whenever necessary. Preparing the standard solution of a solute, we need to, here, this is the table which will reflect the molecular weight of the substance or solute that is available in our laboratory. And this ammonium chloride has been calculated for your reference, and the molecular weight is 53.5. In the similar way, the other compounds have been calculated and mentioned here. So this will help us to create or prepare the solution with standard concentration or known concentration. One mathematical representation we can use to find out how much solute is required to prepare certain solution having a definite concentration. The equation is something like this: amount of reagent if that is A, that would be equal to the V multiplied by C and MW. Here V stands for volume of the solution, that means how much solution we want to prepare. C is the concentration of the solution, how much concentration we want, what would be the concentration of the solution, and MW is the molecular weight of that particular substance. By using this equation, by changing the format of this equation, we can create other equation. Here one of the examples, uh, how much sodium chloride is required to prepare 400 milliliter of 2.24 molar sodium chloride solution. Here we do not know how much required, but we know that what would be our volume and what would be the concentration. So here V and C is known, and as it is sodium chloride, so the molecular weight would be 58.4. You can write 58.5 or exactly 58.44. If you put the value there, you will get how much sodium chloride is required. As the definition of concentration was given in liter, so we need to convert the volume into liter. 400 milliliter would be converted into liter like 0.4, and concentration already given in the molar M, so don't need to be changed. And molecular weight 58.44. If you put the value, then you will get 5.61 gram. So now simple, take 5.61 gram sodium chloride and make a solution of 100 milliliter by adding the solvent. Here the water would be the solvent, as it is not mentioned. So just whenever you will prepare the solution with 400 milliliter, having dissolving this 5.61 gram of sodium chloride, the concentration would be 0.24 molar. Another example for sodium nitrate, how much sodium nitrate is required to prepare 2 liters of a 1.5 molar sodium nitrate solution. So here a bigger, and also the concentration is very high. Earlier was only 0.24, this is 1.5. So you put the value there, you don't need to change anything because it is already in the liter. Volume is 2, concentration is 1.5, and molecular weight is 85. So we need 255 grams of sodium nitrate to dissolve sodium nitrate, 255 sodium nitrate, and if we dissolve this amount in 2 liters of water, then the concentration would be 1.5 molar. So this is the basic for making the solution. And earlier I told you that whenever we need to dilute the solution, we will add the solvent. The dilution is given with the equation here. When we need to dilute the stock solution, we can easily use this equation. If you are working in a chemistry lab, it is essential to know how to calculate a dilution. Here is the reason here. So M dilution and V dilution. M dilution means the concentration of the diluted solution. That means what we want concentration, and volume of the diluted, how much diluted solution we require. And M is the stock solution. That means how much, what would be the concentration of the stock solution, and V volume of the stock solution. Written nicely. Let's have an example. What volume of stock solution of 0.24 molar sodium chloride is required to prepare 75 milliliter of 0.1 molar sodium chloride? Here we need the molarity of the volume of the stock solution. Others are given. This is the solution 0.24 sodium chloride, already the stock solution, molarity of the stock solution, and the dilution. That means if we dilute, how much solution we require, or 75 milliliter. So the volume of diluted solution 75 milliliter, and the molarity, that means the concentration of the diluted solution would be only 0.1. So if you put the value there, then the V stock, that means the volume of stock solution is found here, 31.25 milliliter. Now if we take the 31.5 25 milliliter of stock solution, and if we make it 75 milliliter by adding the water, that means the solvent, then the concentration will be decreased from 0.24 to 0.1. So this is the dilution calculation. Now we are going to I'm going to share a demonstration with you so that you can understand clearly the total process. Before that, I would like to give you the attendance, then we will join after the first session complete.